These days, we usually ask Siri, "Hey Siri, how far is the nearest fuel station?" Whenever we ask something to Siri, the powerful speech recognition system gets to work and converts the audio into its textual form. Then is then sent to the Apple server for further processing. And then machine learning algorithms are run to understand the user's intent. And then finally, Siri tells you the answer. Well, this is happening because of these machine learning algorithms. Hey everyone, I'm Mayank from Simplilearn. In this video, we will learn what an algorithm is. We will look at what machine learning is, followed by machine learning types. We will continue this session by understanding how algorithms work in machine learning, followed by how algorithms work in programming. Further, we will also see some popular machine learning algorithms in detail. At last, we will end this video by seeing some hands-on lab with Python code. But before we begin, if you haven't subscribed to our channel, hit the subscribe button and please don't forget to press the bell icon so you will never miss any update from Simplilearn. So without any further ado, let's begin. In computer programming, an algorithm is a set of well-defined instructions to solve a particular problem. It takes a bunch of information sources and delivers the ideal result. Most of us must be using a Snapchat to apply filters on your faces while making videos or capturing photographs. But do you know how does Snapchat recognize your face while capturing videos or photographs and put filters on it? Even if there are multiple faces, it applies filter on every face accurately. This became possible with the help of face recognition technique, which uses machine learning algorithms to detect faces and apply required filters on them. So, this is the basic idea of how an algorithms work. Let's move ahead in this video and we will now discuss how an algorithm works in machine learning. But before that, let's go through what is machine learning. Machine learning is a subpart of artificial intelligence, the art of making computers learn and act like humans by feeding data and make predictions based on experience. As we saw in previous example, when the data, that is, how far is the nearest fuel station, comes in, the machine, or in our case Siri, immediately start analyzing data. And machine accurately makes prediction and decision based on given data. Now that we have an understanding of what machine learning is, let's move forward and discuss different types of machine learning. Machine learning is classified into supervised learning, unsupervised learning, reinforcement learning. There are two sort of problems in supervised learning: classification and regression. Certain types of machine learning algorithms fall under the classifications are decision algorithm, KNN algorithm, logistic algorithms, naive-bayes algorithm, support vector machine algorithm (SVM). However, in regression types of machine learning algorithms are linear regression, regression trees, nonlinear regression, and Bayesian linear regression. Now, talking about unsupervised learning, there are two sorts of problems in unsupervised learning: clustering and association. Algorithms that fall under clustering problems include K-means clustering algorithms, principal component analysis algorithms. However, algorithms that fall under association problem are Apriori algorithms, FP growth algorithms. In reinforcement learning, there are two types: positive reinforcement, negative reinforcement. Reinforcement learning algorithms are mainly used in AI applications and gaming applications. There are certain types of problems which falls under reinforcement learning are Q learning, state action reward state action SARSA algorithms, deep Q neural network and Markov decision process. After discussing what machine learning is and its type, let's move forward to see how algorithms work in machine learning. Everyone knows the algorithm is a step-by-step process to approach a particular problem. There are numerous examples of algorithms, from figuring out sets of numbers to finding routes through maps to showing data on a screen. Let's understand this by using an example. Every algorithm is built on inputs and outputs. Google search algorithm is no different. The input is the search field and the output is the page of result that appears when you enter a particular phrase or keyword, also known as SERP or search engine result page. Google has a search algorithm so it can sort results from various websites and provides the user the best result. When you start a search, you will see the search box. Will attempt to guess what you are looking for. In order to better understand what the user is looking for, the algorithm is trying to gather as many as suggestions from them as possible. The results from the search field that best matches the query will be ranked. The choose with website will rank and in what position using more than 200 ranking variables. Now let's take an example of coding program and see how the algorithm works. Here, we will use a case of computer program wherein we want to print the multiplication table of any number. Let's take 2. The algorithm start here and then it assign a value to a variable. The variable I is having an initial value of 1. The system will read the number. The number in case is 2. Now, the system has a condition. A condition can now either be true or false. If the value of I reaches 11, then the loop will end. Otherwise, value of I will multiply by the number. The initial value of I is 1. So, for the first time, the system output will be 2. Now, value of I will be increased by 1. According to the loop condition, the system will then move back and check for the condition again. The new value of I is 2, which is still less than 11. The system will again print 2 into I, which is 2 into 2 on the screen. The new output result will be 4. The system will keep following the same procedure repeatedly until the value of I becomes 11. Once the value of I becomes 11, then only the algorithm will terminate. After discussing how an algorithm works, let's move forward and see some popular machine learning algorithms. Some popular machine learning algorithms are: first one is linear regression algorithm, second one is logistic regression algorithm, and the third one is decision tree, and the fourth one is support vector machine algorithm SVM, and the fifth one is KNN, K nearest neighbor algorithm, and the sixth one is K means clustering algorithms. And the seventh one is random forest algorithms. And the last but not the least algorithm is Apriori algorithms. Let's go through them in detail one by one. Linear regression is one of the most famous and straightforward machine learning algorithms utilized for predictive analysis. Linear regression shows the linear connection between the dependent and the independent factors. The equation of line is y equals to mx plus b. Here, y stand for the response variable or a dependent variable, whereas x is for the predator variable or an independent variable. It attempts best to fit line between the dependent and the independent variables, and this best fit line is known as line of regression or regression line. Let's take a real application example. In predicting consumer behavior, businesses use linear regression to forecast things like how much a client is likely to spend. Things like targeted marketing and product development may benefit from this. Walmart, for instance, use linear regression to forecast which good would be in high demand across the nation. Moving forward, let's see types of linear regression. There are two types of linear regression algorithm. The first one is simple linear regression and the second one is multiple linear regression. In simple linear regression, if an independent variable is utilized to forecast the worth of a mathematical dependent variable, then at that point, such a linear regression algorithm is called simple linear regression. The equation of line will be y equals to a0 plus a1x. And the second one is multiple linear regression. If the dependent variable declines on the y and the independent variable on the x, then such a relationship is known as negative linear relationship. The line of equation will be minus of a0 plus a1x. Moving forward, let's see logistic linear regression. Logistic regression is the supervised machine learning algorithm utilized to anticipate all the categorical factors or discrete values. It could be very well used for the grouping issues in machine learning. And the result of the logistic regression can be either yes or no, 0 or 1, man or woman, and so on. It gives the values which lies between 0 and 1. For example, a credit card business is interested in knowing whether the transaction amount and the credit score have an impact on the probability that a particular transaction would be fraudulent. The business can use logistic regression to determine how these two predator values can relate the probability that a transaction is fraudulent. The response variable in the model has two possible outcomes. First one is the transaction is fraudulent, and the second one is the transaction is not fraudulent. In logistic regression, rather than fitting a regression line, we fit an S-form logistic capability, which predicts two greatest values, 0 or 1. The logistic regression equation can be calculated from linear regression equation. The steps to get logistic regression equations are: the equation of a straight line can be written as y equals to b0 plus b1 x1 plus b2 x2 till bn xn. In logistic regression, y can be between 0 and 1 only. So for that, let's divide the above equation by 1 minus y. Then the equation will be y upon 1 minus y, that is 0 for y0 and infinity for y equals to 1. But range between minus infinity to plus infinity, then we have to take the logarithm of equation, and now it will become log of y upon 1 minus y equals to b0 plus b1 x1 plus b2 x2 so on till bn xn. Let's move forward and see types of logistic regression. There are three types of logistic regression that can be classified. First one is binomial. In binomial logistic regression, there can be only two possible types of dependent variables like yes or no, pass or fail, man woman, and many more. And the second one is multinomial. In multinomial logistic regression, there can be three or more possible unordered ways of dependent variable such as horse, cow, and sheep. And the last one is ordinal. In ordinal logistic regression, there can be three or more possible ordered ways of dependent variable, such as small, medium, or large. Moving forward, let's see decision trees in detail. A decision tree is a tree structured classifier that could be used for classification and regression. A decision tree is a tree in which each non-leaf node is assigned to an attribute. Additionally, each arc contains one of the available values for its parent node, which is associated with each leaf node, that is, the node from where the arc is directed. Let's see some decision tree terminology. First one is root, that contains the entire data set. The next one is node, a test for the data of a certain attribute. And the third one is branch, which connect the node to internal node or the internal node to leaf node. And the fourth one is leaf node, the terminal node that predicts the outcome. Let's move forward and see decision tree algorithms. The first one is select the best attribute to use the current node in the tree. The second one is for each possible values, select the attributes. The third one is partition the examples using the possible values of this attribute and assign these disjoint subset of the example to the appropriate child node. Recursively generate each child node until ideally all examples for a node have the same label, like class. Moving forward, let's understand the decision tree. For building a decision tree, step 1 is select an attribute. Then split the data into its children in a tree. Continue splitting with available attributes and keep splitting until leaf nodes are pure, like only one class remains, a maximum depth is reached, a performance metric is achieved. Let's move forward and see SVM algorithm, support vector machine algorithms. A support vector machine is a well-known supervised machine learning model. It is utilized for both information, classification, and regression. It is regularly utilized for the grouping issues. We can involve it in different life care system, and we can involve it in typically happy or sad look arrangements. We can involve it in filters. If we make specific looks, it would add the particular filter according to the expression. The scope of articulation lies between happy and sad. Support vector machine helps in to recognize handwritten characters used widely, like checks continue to be a significant part of the majority of non-cash transactions and are frequently written by the pupil. The current check processing system in many developing nations involves a bank employee to read and manually enter the information in a check, while also verifying the data like signature and date. A handwritten text recognition system can reduce expenses and labor hours because a bank must handle several checks each day. Moving forward, let's see the algorithm of SVM. The objective of support vector machine is to make the best line or choice limit that can isolate n-dimensional space into classes. So we can undoubtedly put the new data of interest in the right category. Later on, this best decision boundary is known as a hyperplane. Let's move forward and see types of support vector machine. Support vector machine can be of two types. First one is linear SVM, second one is non-linear SVM. Let's move forward and see linear SVM. Linear SVM is utilized for linearly detachable information, which implies if a dataset can be ordered into two classes by utilizing a straight line, then such information are named linearly separable information. And a classifier is utilized called linear SVM classifier. Moving forward, let's see nonlinear SVM. Nonlinear SVM is utilized for non-directly isolated information, and that implies in the event that a dataset can't be categorized by utilizing a straight line. Such information is named non-directed information, and the classifier utilized is called a nonlinear SVM classifier. Moving forward, let's see KNN algorithm in detail. KNN is a supervised learning technique. KNN classifies new data into a targeted classes depending on the features of its neighboring points and also be used for the regression problems. It is an instance-based learning algorithm and a bit lazy learning algorithm. KNN calculation stores every one of its accessible information and orders another information point based on the likeliness. This means that when new data information appears, it usually tends to be successfully categorized into a good suit classes using the KNN algorithm. Let's imagine we have an image of animal that resembles a cow or ox. However, here we are not sure if it is a cow or ox. As KNN method is based on a likeness matrix, it will identify the properties of new data that are related to the image of cow or ox. And based on those quality, it will classify the data as belonging to either cow or ox group. Moving forward, let's see how does KNN work. The steps to implement KNN algorithms are: Step 1. Decide on the neighbors' k numbers. Step 2. Calculate the Euclidean distance between k neighbors in step 2. Third one is, based on the determined Euclidean distance, select the k closest neighbors. Step 4 is, count the numbers of data points in each category between these k neighbors. Step 5. Assign the fresh data points in the category where the highest neighbors count. And then KNN model is ready. Let's say we need to add a new data point to the vital category. At first, we will decide on the numbers of neighbors. Therefore, we will pick k equals to 5. Then, the Euclidean distance between the data points and then can be determined. The distance between two points known as the Euclidean distance can be determined by under root of x2 minus x1 ka whole square plus y2 minus y1 whole square. Then we determine the closest neighbors by calculating the Euclidean distance. There are three closest neighbors in category A and two closest neighbor in category B. This new data point must fall with category A because as we can see its three closest neighbors are also from group A. After understanding KNN algorithm, let's move forward and see k-means algorithms in detail. The k-means is a cluster false. Under that is an unsupervised learning algorithm. It is used to address machine learning clustering problems and utilized to tackle the grouping issues in machine learning. It permits us to bunch the information into various gatherings. It is a helpful method for finding the classification of groups in the unlabeled dataset without the requirement of any training. This k-means algorithm groups the data into similar classes. Let's see some application of k-means clustering. Let's see some applications of k-means clustering. Diagnostic system. The medical profession uses k-means clustering in creating smarter medical decision support system, especially in the treatment of liver alignments. The second one is search engines. Clustering forms a backbone of search engine. When a search engine is performed, the search result need to be grouped, and the search engines very often use clustering to do this. Moving forward, Let's see how k-means algorithm works. The steps to implement k-means algorithms are: Step 1. Select the number k to set the number of clusters. Step 2. Select a random k points or centroid. Step 3. Assign each data point the closest centroid that forms to predefined k cluster. Step 4. Determine the variance and set a new gravity points for each cluster. Step 5. Repeat the third step. This means reallocating each data point to the new closest centroid cluster. Step 6. If a reassignment occurs, go to step 4, otherwise go to exit. Step 7. The model is ready to use. So now we have a clear understanding of how k-means algorithm work. Let's move forward to see the graphical representation of k-means algorithm. Consider that there are two variables m1 and m2. This is a scatter plot of these two variables along the x and y axis. We should accept the number of k of bunches, that is k equals to 2, to recognize the dataset and to place them into various groups. It implies here we will attempt to bunch these datasets into two unique groups. We will really want to pick an irregular k point or centroid to frame this group. These centroids can be either the focus of the dataset or some of other points. Thus, here we are choosing under 2 points as k points, which are not the piece of our dataset. We will assign every data of interest in the scatter plot to the nearest k point or centroid. We will register it by applying some math that we consider to find the distance between 2 points, that is Euclidean distance. Thus, we will draw a median between both the centroids. From the graph, the left half of the line are close points to the right and the k1 centroid. Green is near the orange centroid. We should variety them as green and orange for clear representation. As the need might arise to track down the nearest group, we will repeat the cycle by picking another centroid. To pick the new centroid, we will figure out the center point of gravity of these centroids and will track down new centroids. Then we will reassign every piece of information to highlight new centroid. For this, we will repeat a similar course of tracking down a middle line. The middle will be like as seen in the picture. One orange point is on the left half of the line and two green points are on the right. Thus, these 3 points will be appointed to the new centroids. As reassignment has occurred, we will again go to step 4, tracking down new centroids or k points. We will repeat the cycle by tracking down the center point of gravity of centroids. So the new centroids will be displayed as like this. We now have new centroids, so once more define the middle boundary and reassign the data of interest. By this graph, there are no unique pieces of information on one or the other side of the line, implying our model is shaped. By the previous graph, there are no unique pieces of information on one or the other line, implying our model is shaped. As our k-means model is ready, and the two last groups will be displayed as like these. Now we have a clear understanding of how k-means clustering algorithm works. Now let's move forward to understand random forest algorithm. Random forest is an adaptable, simple to utilize machine learning algorithm that produces, even without the hyperboundary tuning, an extraordinary outcome more often than not. It is likewise quite possibly the most utilized algorithm because of its effortlessness and variety. Like it tend to be utilized for both grouping and classification tasks. Random forest is a classifier that contains various choice trees on different subsets of the given dataset and takes the normal to work on the present exactness of the dataset. Instead of depending on the choice tree, the random forest takes the forecast from each tree and in light of the larger part of votes of expectation, it predicts the final result. Now let's move forward and see how does random forest work. We should see the random forest in order since the arrangement is now and again thought to be the structure block of machine learning. This is what a random forest would look like with two trees. The random forest has a similar hypermeter to our decision tree or a Bayesian classifier. Luckily, there is a compelling reason need to consolidate a decision tree with a Bayesian classifier, since you can undoubtedly utilize the classifier classes of random forest. With random forest, you can likewise manage tasks using the algorithm regression. Random forests add extra arbitrariness to the model while developing the trees. Rather than looking for the main element while parting a node. It looks to the best component among an irregular subset of highlights. These outcomes in a wide variety often result in a superior model. Subsequently, in a random forest, just a random subset of the element is thought about the algorithm. You might make trees more random by involving random edges for each component instead of looking for the most ideal limits like a typical choice tree does. Let's move forward and see some application of random forest algorithms. Random forest is involved at work by researchers in numerous ventures, including banking, stock exchanging, medication, and many more. It is utilized to predict things which assist these businesses with running productively, like client activity, patient history, and safety. In banking, random forest is used to identify clients who are more likely to pay back their debts on schedule. Additionally, it is utilized to forecast who will make more frequent use of bank services. Even fraud detection uses it. The Robin Hood of algorithms, indeed. Random forest is a tool used by stock traders to forecast future stock behavior. Retail businesses utilize it to make product recommendation and forecast client satisfaction. Random forest can be used in healthcare industry to examine a patient medical history and detect disorders. Random forest is a tool used by pharmaceutical experts to determine the ideal mix of ingredients in treatment or to forecast drug sensitivity. By seeing application of random forest algorithm, let's move forward and see some difference between decision trees and random forest. Let's see the difference between random forest and decision tree. The first one is while building a random forest, the number of rows is selected randomly. In decision trees, it builds several decision trees and find out the output. The second one is it combines two or more decision trees together. In decision trees, whereas the decision is a collection of variables or datasets or attributes. The third one is it gives accurate results, whereas it gives less accurate results. The fourth one is by using random forest, it reduces the chance of overlifting, whereas decision trees it has the possibility of overlifting. The fifth one is random forest is more complicated to interpret, whereas the decision tree is simple, it is easy to read and understand. After seeing what is random forest, how it works, let's move forward to see Apriori algorithms in detail. The Apriori algorithm utilizes standard item sets to create affiliation rules and is intended to chip away the information bases containing exchanges. With the assistance of these affiliation rules, it decides how firmly or feebly two objects are associated. This algorithm utilizes a breadth first search and hash tree to work out the item set association effectively. It is the iterative interaction for finding out the successive item set from the huge dataset. Let's move forward and see steps for a priori algorithms. The steps for a priori algorithms are step 1 is establish minimal support and confidence for item set in the transactional database. The second one is take all transaction supports with a greater support value, the minimum or chosen support value in step 2. The third one is track down all the rules in these subsets with confidence value greater than the threshold value. The fourth one is arrange the rules to lower the lift. At last, we will see some advantages and disadvantages of a priori algorithm. The advantages of a priori algorithms are easy to understand an algorithm, and the second one is the join and prune steps of the algorithms can be easily implemented on the large dataset. The disadvantages of a priori algorithms are the a priori algorithms work slowly as compared to the other algorithm. And the second one is the a priori algorithms times and space complexity are O of 2D, which is very low compared to the other ones. Let's move forward and see some hands-on lab demo. So we will see a hands-on lab demo on linear regression. As we know, linear regression is a way to find or to predict the relationship between two variables. Generally, we use x and y. So first we will open command prompt to write command to open Jupyter Notebook. So we will here write Jupyter Notebook and then press enter. So this is the landing page of Jupyter Notebook and select open new Python file So this is how Jupyter Notebook UI looks like. So at first we will import some major libraries of Python, which will help us in mathematical functioning. So the first one is NumPy. NumPy is a Python library used for working with arrays. It also has functions for working in domains like linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So we will write like import NumPy as NP. Here NP is used for denoting NumPy. So we will import the next library is Pandas. Pandas is a software library written for Python programming for like data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical labels and time series. So we will write import pandas as PD. Here, PD is used for denoting pandas. So our next library is matplotlib. Matplotlib is a graph plotting library in Python that serves as a visualization utility. Matplotlib is open source, so we can use it freely. And it is most written in Python, a few segments in C and JavaScript for platform compatibility. For importing matplotlib, you have to write import matplotlib dot pyplot as plt. So after importing the libraries, we will move ahead and import dataset. So for importing dataset, we have to write dataset equals to pd dot read underscore csv, and here we have to give the path of the file dataset dot csv. Here pd is for pandas library and read is used for reading the dataset from the machine, and csv is used for the type of file which you want to read. So after reading, let's see our data. So we will write dataset dot head and press enter. Here head is used for retrieving the first 5 lines from the data, so our data is coming properly. So moving ahead, now let's first define x and y axis. For x, we have to write x equals to dataset dot ilog bracket colon comma colon again -1 dot values for x axis, and for y axis we have to write y equals to dataset dot ilog bracket colon comma 1 dot values. So if we will use dataset dot ilog for -1 values for x axis, it will select till the second last column of the data frame instead of the last column. And I know this is as the second last column value and the last column value for the row is different. Whereas if we will use for the y-axis, values return a series vector. A vector does not have a column size. So moving ahead, let's see the value for x and y-axis. First, we will see the value for x, like just you have to write x and press enter. So these are the arrays value for x, and for y-axis you have to type y and then enter. So these are arrays value for y-axis. So after this, now let's split the dataset into training and testing. Separating data into training and testing set is an important part for evaluating data mining models. Typically, when you separate a dataset into a training set and a testing set, most of the dataset is used for training and a similar portion of dataset is used for testing. So we will split it into 70 and 30 ratio. So for splitting, we need to import some more libraries for this process. So we will write from sklearn dot model underscore selection import train underscore test underscore split. Scikit-learn, like sklearn, is most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, and clustering. So after importing, let's write code for the splitting data. So we will write here x underscore train comma x underscore test. comma y underscore train, comma y underscore test equals to train underscore test underscore split. In brackets we have to write x comma y comma test underscore size equals to 0.3 comma random underscore state equals to 0. Random is with random state equals to 0, we get the same train and test sets across different execution. So after this, let's see the values together. So we will write x underscore train comma x underscore test comma y underscore train comma y underscore test. So these are the values of array x and array y together. Moving ahead, now let's work with regression. First, we need to import the library for regression. So we will use from sklearn dot linear underscore model import linear regression. We already discussed sklearn is used for machine learning and linear regression. Is a major part of machine learning. So after this, let's make a function for regression as reg for easy use. So we will write reg equals to linear regression and brackets. First, we try to train and then test and compare. So we will write here reg dot fit bracket x underscore train comma y underscore train. Now let's predict values, but prediction values are always different. So we will predict values for y first. So we will write y underscore predict equals to reg dot predict or x underscore test. So like y underscore predict, then enter. This is when the predict functions come into the picture. Python predict function enables us to predict the labels of the data values on the basis of training model. The predict function accepts only a single argument, which is x underscore test here, usually the data to be tested. So when you will check the value for y test, you will see the different values like y underscore test. So you can see there are totally different values from x-axis. Now let's display on graph for training dataset. So we have to write plt dot scatter x underscore train comma y underscore train comma color equals to, you can choose by yourself, I will choose red, and then plt dot plot x underscore train comma regression point for predicting values for x underscore train comma color equals to blue. So this color is for the regression line, and the plt dot title linear regression, regression salary versus experience, and I will prefer the size would be 18. So let's set the labels for x and y axis. So x label year of employee, comma size will be, I will prefer size will be 50. Then for y axis we will write here like salaries of employee. And I will prefer this same size 15. Let's show the plot by writing plt.show. Then hopefully we are fortunate, everything is going to be fine. Perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression work for training data set. Let's see how it will work for testing data set. Now let's predict for test data set. You can copy for the same and like you can change it. So we can copy here. So we can paste here. So we have to just change here train to test data set. Test here, then again test here, then again test here. Everything we will reduce some size to 16. Let's see. Then it will reduce 12 and it will be 12 and so perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression works for testing data set. This video has introduced you to machine learning. You realize that machine learning is a strategy of preparing machine to play out the exercise a human brain can do, though a bit quicker and better than a typical person. Machine learning can be supervised or unsupervised. If you have the lesser amount of information and are named for the preparing, opt for supervised learning. Unsupervised learning would for the most part result in better execution and enormous data sets. We have reached the end of this video. I hope you guys found this video informative and helpful. If you have any doubts or feedback, comments below and allow us to assist you. Don't forget to click the bell icon if you enjoyed the video and subscribe to our Simplilearn YouTube channel. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.